Welcome students. I am Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. In my lecture series, today I am going to deliver my lecture of MSc Final Physics. In my previous lectures, I have discussed DC and AC Josephson effect. Before moving on to today's topic, I am going to describe you what I discussed in my previous lecture. Students, we have discussed Josephson effect. As we know, when we have two superconductors which are separated by an insulating layer, then if this insulating thin layer is very thin, then only electrons can cross from one superconductor to another superconductor. That means this insulator acts as a barrier. So, this Josephson effect is the phenomena of current flow across two weakly coupled superconductors which are separated by a very thin insulating layer. Now, since there are two superconductors and between them, this insulator is a non-conducting barrier. This arrangement of two superconductors which are linked by this non-superconducting barrier, this is known as Josephson junction. And the current that is flowing across this barrier, this current is, students, Josephson current. On this basis, we have discussed DC and AC Josephson effect. What were these two effects? According to DC Josephson effect, if we have this arrangement, that is two superconductors which are separated by a thin insulating layer and there is no electric or magnetic field applied, then in this case, we have in output a current which is DC in nature. This is DC Josephson effect. That means in spite of any current or voltage source, there is the output current and that is DC. Now, AC Josephson effect. What is AC Josephson effect? On this insulating layer, if we apply a DC voltage source, then in the output, we will get RF oscillations. That means in the output, the current is alternating current. So by applying a DC voltage, which is a barrier, across the barrier, we get a current that is alternating in nature. Now, based on these two effects and Josephson effect, there is one more effect, which we will discuss in detail today. This effect is known as macroscopic quantum interference. What is this effect? Here, we will take two junctions. As in DC and AC, we have simply two superconductors which were separated by insulating layer. But in this case, that is macroscopic quantum interference, we will take two such type of junctions and we will show that due to interference effect, the output has a current. What is this effect? Here I am showing this by a diagram. This diagram shows that there are two Josephson junctions, 1 and 2. These two junctions, they are attached in parallel. Now, this is superconductor, this is also superconductor, and this block shows an insulating layer. So, a tunneling junction has been formed. I am denoting my first junction by a letter A and another by a letter B. Assuming that the phase difference between my point 1 and 2, when I am taking through a path A, it be delta A, and when taken through path B, let it be delta B. Now, initially, I am applying zero magnetic field. That means no magnetic field is passed, hence magnetic flux will be zero. So flux is zero. That means the phase difference across these two junctions will be same. Assuming we have already taken the phase difference delta A, delta B, these two will be equal. Delta A will be equal to delta B. Now I am applying a magnetic field in the interior of the specimen. That means in this interior. So by applying a magnetic field, a flux will be generated. This magnetic field, or we can say that flux can be generated through by using a straight solenoid. Now, because a magnetic flux has been introduced, delta A will not be equal to delta B. There will be variation in the phase, and the variation will be equal and opposite because these two junctions are connected in parallel to each other. Assuming that delta 0 to be the initial phase. So the phase across the first junction, that is A junction, will be del 0 minus E phi upon H cross C. And similarly, the phase difference across the B junction will be del 0 plus E upon H cross C phi. In one case, it will be minus, and in another case, it will be plus. Opposite sign will be there. Now, in the output, we will have a current through both the junctions. That means in the output, there will be current through A junction denoted by IA and current through B junction denoted by IB. So the total current, output current will be the sum of JA plus JB, IA or JA plus JB. Since we know the phase of A and B junction, we can write J0 sine del 0 plus E phi upon H cross C plus sine del 0 minus E phi upon H cross C. Solving this, we get 2J0 sine del 0 cos E phi upon H cross C. This is the total output current. Now, since in this total current, the initial phase is constant. Variable is E phi upon H cross C. This current, total current, will have a maxima when E phi upon H cross C is a multiple of pi. Here S is an integer. That means this is an current which depends upon the phase difference, and the phase difference occurs through the flux phi. So this effect is known as macroscopic quantum interference effect. These Josephson effects, they have found variety of applications. The major application is in squid. What are squids? They are termed as superconducting quantum interference device. They are used to detect magnetic signals. Another use of Josephson effect is in meteorology. This effect provides an exact reproducible conversion between frequency and voltage. Other application is Josephson junction are integral in superconducting quantum computing as qubits. This is the most important application of superconductors when they are used in the form of Josephson effect. They are also used in superconducting tunnel junction detectors, which are also termed as STJ. So, students, this Josephson effect is very important in superconductivity. I hope you must have learned what I taught you today. Thank you for watching.